Hi everyone, welcome. I think we've hung on as long as we can. So we're going to start our presentation today, and I'm super excited to welcome Millie to give the talk today. I've obviously seen the talk, so I know what she's going to say, and it's very interesting, and Millie's a great speaker. So thank you, Millie, for being willing to do this. I know sometimes it's not easy. So just to give you an intro to Millie. She's a Canadian fashion designer and second-year master's student in the TMU MA fashion program. And prior to her graduate studies, Millie was a senior designer for Group Dynamite Inc., where she worked for women's wear brands Garage and Dynamite. Her industry background has informed her research focus on the transformative potential of 3D design technology for fashion design. That's quite a mouthful. Her master's research examines the impact of 3D visualization tools on the design processes, creativity, and sustainability considerations of mass market fashion designers using human-centered design approach. So that's quite a bio, and she's going to talk about this type of stuff in our talk today. And this is our third and final session in the fashion series that we started in the fall of last year. And our first speaker is with us, Hayley, who kicked off our session. Hayley, do you want to wave? So remember that we have a networking at the end of this, and the whole point of the talk and the networking is for people to talk to each other and build a sense of community around fashion, textiles, and science and wearables. Obviously, you're in a hospital. And when I started these fashion talks, I wasn't entirely sure how it was going to go, bringing fashion talk into a hospital environment. Little did I know that people were really interested in this area. So I'm hoping we have some scientists here, and obviously on streaming, if you've got any questions, please push those through. So please stick around, introduce yourselves to each other. We're trying to build community around these subjects. It's one of the key aspects of the Kite Creates initiative. And obviously you're getting to know us more with Kite Creates. We've been going since September. And we're trying to bridge between science and the creative industries. And we're particularly looking at wearables in the fashion series. So just before I get going, because this might seem like it's going to be a little bit disruptive, but we've also got a class from North Bendale School coming in on this side of the room. Now their bus got delayed. Obviously, that was bound to happen this morning. So they're going to be coming in a little bit late. So I'm hoping it's not going to disrupt you, Millie, too much and disrupt the rest of the audience. And the class will have a couple of questions at the end as well. They're currently on a tour of the labs that we've got here. So they'll be coming in, so don't be shocked by that. And what else should I say? Stick around for the networking session, talk to each other. That's the biggest thing, talk to each other. And yeah, we're going to start. Over to you, Millie.
Thanks so much. Just double checking, I don't need to have anyone turn on my mic. I'm good to go, perfect. It's really great to be with you here today. I'm excited to be the third presenter in Kite's three-part series on the intersections of fashion and technology. And I know that it's likely that some of you here today have attended the lectures of Hayley Stolee-Smith and Ronald Tam. Today, I'll be contributing a digital fashion lens to this series as I introduce you to the world of virtual prototyping and avatars for fashion design. The world of virtual prototyping is quite rapidly expanding and evolving as the industry turns towards these 3D visualization tools to minimize waste, time, and cost. Relative to other design fields like architecture, industrial design, and interior design, the widespread use of these 3D tools in fashion is a more recent phenomenon. And the early adopters of these tools are beginning to shape its uses and role in the design workflow. I think that makes it very exciting for me to be here in front of you today, especially in front of such a diverse audience, to get you thinking about the role that 3D tools could play in the development of adaptive or specialty apparel. And we're just going to start off with a land acknowledgement. So we acknowledge that the events and meetings we host take place on land traditionally inhabited and cared for by First Nations. Toronto is the traditional territory of many First Nations, including the Mississaugas of the Credit, the Anishinaabeg, the Chippewa, the Haudenosaunee, and the Wendat peoples. We will come back to these slides once the group arrives. Today, I'm going to be covering a kind of broad range of topics to acquaint you with virtual prototyping, as well as some of its applications for the development of adaptive apparel. I'll begin by covering the scope of digital fashion, as well as discuss its origins from the early invention of the jacquard loom to more present-day technologies. Next, we'll take a look at the digital design process and its impact on various user groups, including designers, pattern makers, vendors, and marketing teams. Following this, we'll take a look at virtual avatars and the body scanning process, and discuss how it might be used to support the design process for diverse bodies and mobility differences. The last section of my talk will focus on 3D design and sustainability, looking at the impact of these tools on both pre- and post-consumer waste. I'll wrap up with some closing remarks, and then of course we'll have time for questions and answers. So to tell you a little bit more about me, like Helen mentioned, I'm a former senior fashion designer for 2 Canadian womenswear brands, I think, but most importantly to this lecture, I am a MA fashion student at Toronto Metropolitan University. My experience in the fashion industry exposed me to some opportunities and challenges with integrating 3D tools into the design process. And this has led me to the pursuit of my major research project at TMU, which is a qualitative study investigating the impact of these tools on design process, as well as how these tools are kind of shaping and evolving the role of the designer. In addition to my personal research, I'm an avid enthusiast of 3D design tools, and I've also taught 3D design workshops for fashion professionals at TMU. So to kick off today's talk, I'd like to just begin by asking the simple question, what is virtual fashion? The definition that I like to use is quite broad and not overly specific. And the reason for this is that the digital fashion is a relatively new sector of the fashion industry. And as this kind of rapidly evolving field, I think it requires some flexible language to account for the changes that it's sure to undergo in the coming years. Virtual or digital fashion refers to dematerialized garments, accessories, or skins created in a digital environment. And it can have bearing in the physical world as a virtual prototype informing the development of a material sample, or exist purely in virtual form. There are kind of 3 key types, the first being those virtual prototypes for the visualization of physical garments, applied digital fashions like filters and virtual try-on technology, and omni-virtual fashion, which includes garments for gaming, the metaverse, and other virtual environments. Dr. Siam is a key digital fashion thinker and the leader of the Digital Fashion Network, which is an interdisciplinary network that connects academics and industry professionals engaged with fashion and technology. And he's created this 4-part framework that explains kind of the scope of digital fashion, splitting it into 4 parts. His framework centers the role of technology in digital fashion as opposed to its end products. And in our presentation today, we'll touch on 3 of these 4 aspects: digital human in the metaverse, digital business and promotion, and the more central focus of today's talk, which is digital design and e-prototyping. The final quadrant, digital apparel and smart technology, was covered by Hayley in the first part of this lecture series. Like I mentioned at the start, the use of these tools is kind of a relatively new thing in fashion. And a contributing factor to fashion's kind of relatively late adoption of these tools is not only the complexity of textile modeling, but the fashion industry as a whole's kind of laggard approach to the use of new technological tools. And while we're beginning to see these brands kind of settle into their use of these 3D tools, the digital landscape is quite rapidly evolving, with things like AI, augmented reality, and virtual reality shifting the way that fashion is not only designed, but also produced and consumed. With that said, the roots of digital design and e-prototyping trace back as far as the 19th century, with the invention of the punch card loom and a mechanism designed to lift warp threads, which automated labor-intensive textile making processes. These inventions came to be combined in 1804 by weaver Joseph Marie Jacquard in a mechanized attachment that came to be known as the Jacquard loom. Some of you may already be aware of the significance of the Jacquard loom, which in the mid-19th century served as a starting point for a general-purpose computing machine known as the analytical engine, developed by mathematicians Charles Babbage and Ida Lovelace. The beginnings of virtual prototyping extend to Ivan Sutherland's doctoral thesis at MIT, where he developed a framework for stylus-based digital drawing. The technology that he proposed allowed for the development of 2D computer-aided design tools towards the end of the 20th century. And today, you'd be quite hard-pressed to find any major fashion brand that doesn't make use of these 2D CAD tools like Lectra, Gerber Acumark, and Tucatech. 3D cloth modeling emerged in the early 1990s with some very basic simulation options. And early iterations of today's 3D prototyping tools came from Browseware's development of virtual try-on software, which evolved into the more complex tools that we use today. And though these tools have existed since the early 21st century, it's really the COVID-19 pandemic and fashion's ongoing sustainability crisis that have exploded their use in the last few years. During the pandemic, as borders closed and manufacturing processes were ground to a halt, fashion firms began looking for alternative ways to support their design process. Just with a show of hands, I'm wondering how many of us in the room have either had the chance to try out or are trained to use 3D tools. Oh, it's quite a few, yeah. For those of you who are more unfamiliar, you might be wondering why a brand or designer might choose to use these tools in their workflow. I think the most obvious kind of central benefit is the visualization of flat patterns in 3D prior to the development of a physical sample. But the uses of this tool and their benefits are a bit more comprehensive than this primary use. For those of you who have not had the chance to try out 3D virtual fashion design tools, there are kind of 4 central functions. The first is a 2D pattern making window. So this tool allows users to draft, edit, and construct their flat patterns, either preparing them for production or just using them to workshop design concepts. You are also able to grade pattern pieces. And as we learned about in earlier presentations, grading refers to the process of adding and retracting length and width to fit within a standardized size set. So for instance, small, medium, and large. The second key component is the 3D visualization window. This allows users to preview the outcome of their 2D garments in real time by sewing their garments and constructing them on top of a virtual avatar. The 3D window will realistically simulate textile properties like stretch, drape, weight, and texture. And these properties will in turn interact with the avatar's form. Using this function, much like you could with ordinary clothes, you can tug, pin, stretch, and adjust virtual garments. And in the same way that designers might collect things like fabrics, trims, and notions, 3D prototyping tools also have digital libraries that house virtual assets like avatars, trims, and accessories. With 3D prototyping tools, you can also digitize existing physical fabrics for realistic representation in 3D. So this means that you can be working from pre-existing materials, which might be especially important to the field of adaptive apparel as you might work with specific functional textiles in your work. You're also able to customize avatars to reflect a dress form or client measurements, which I'll touch on in greater detail later on in the presentation. And most of these tools also have these cloud-based virtual libraries where you can store your digital garments and share them with other cross-functional team members, which allows you to get others involved in the design process without needing this kind of more comprehensive training in the 3D prototyping tool. And then the final function that I want to chat about are their rendering and animation capabilities. So much like you'd be able to do in a physical studio setting, you can take high-resolution images or photographs of garments with these editable lighting, background, and camera settings using the tool's rendering functions. And some of these tools also have animation capabilities where you can generate these motion sequences, either preset motion sequences or ones developed using a mocap studio with avatars and garments. And the use of animation here, I think, also has especially strong benefits for the development of adaptive apparel, as you're able to evaluate the fit of the garment in motion. And I'll jump into these benefits a little bit later on. There are a range of 3D prototyping softwares out there, but I wanted to highlight 4 that are quite commonly used in industry, including Clo, Browseware, Style3D, and Optitex. The aims of your organization or project should determine which software you choose. And I did want to highlight a few of the kind of key functions of each program. CLO is known for very strong visualization capabilities and is commonly considered one of the more user-friendly options of the bunch. It evolved out of a program called Marvelous Designer, which is a garment-making tool for gaming and CGI. CLO has those rendering and animation capabilities for presentation, and it also has affordable subscription options for independent designers, which can be a bonus. Browseware is a bit more oriented towards pattern making and fashion production. And from my personal research, people who gravitate towards Browseware are generally looking for more comprehensive and complex pattern making capabilities, and they are more oriented towards corporate licenses. Style 3D was initially oriented more so towards digital fashion artists, but has since expanded into Style 3D Studio, which is a user-friendly virtual prototyping tool. It has individual and corporate licenses, and often its interface is compared to that of clothes. And then finally, we have Optitex PDS 3D, which began as a 2D CAD program, meaning that its roots are in fashion design and production. Their focus is on garment fit and creating production-ready patterns. Today, some of the world's most reputable fashion and apparel brands have begun using these 3D tools, including Canadian brands like Canada Goose, Lululemon, Joe Fresh, and Arc'teryx. This list is kind of ever expanding, and increasingly you'll find that fashion employers are actually seeking out candidates who have experience using these tools. Approaches to adoption can vary quite radically and might be integrated at a kind of variety of stages along the fashion production, production and consumption process. I also think it's important to reiterate that these users of the tools are quite early adopters, as these tools are still really in their infancy. But it's a really exciting time, I think, for the future of fashion as brands turn towards these digital solutions to minimize their sample waste. Oh, I think I might be stuck on my slide. Bear with us. My master's research has been centered on charting this digital design process and observing how the use of these 3D prototyping tools are kind of disrupting more conventional processes of fashion design. Rooted in my research is this underlying philosophy that technology shapes our social world just as we shape technology. But in my professional experience, I had the opportunity to observe how the use of these tools required kind of a reimagining of process as well as some really clear guidelines for their implementation. And I had the chance to kind of observe up close the barriers that various groups involved in the product design process faced as these tools became more commonplace. Oh, perfect. Before we can kind of jump into what the digital design process looks like, I think it's important to establish what a kind of conventional mass market globalized fashion process looks like. In the mass market process, the average garment that you see in stores took a pretty significant journey to get there. And the process really begins with the creation of design concepts. So design concepts can come from a creative direction team, they might come from market research, or they might come from everyday areas of inspiration like art and culture. In the field of adaptive apparel, you might generate design concepts from rigorous user or market research. The design concepts are then distilled into a two-dimensional sketch. And these are referred to as technical flats or, technical drawings or flats. And the purpose of these sketches is to provide kind of a clear directive for the development of a first proto sample, as well as facilitate communication in creating that initial prototype. Typically, these sketches are created using 2D CAD tools like Adobe Illustrator. Next, the designer is charged with the process of a handoff, where they show their sketch to their pattern maker and explain all of the specification and details required for their garment. The pattern maker then transfers this information into a technical package, which includes a digital pattern file and a set of technical details that explain the construction, stitch type, and finishing requirements for the garment. At the same time, the designer also contributes to this technical package, specifying things like fabric, color, and trim details to ensure that that first prototype comes in exactly as they requested. The technical package is then transferred to the manufacturer, who develops a proto sample according to the technical package and sends a sample back to the head offices of the designer. The garment will then typically be fitted on a live fit model, and the comments that they have will be transferred back to the manufacturer. If there are substantial fitting or styling changes to that initial prototype, a second or third fit sample might be requested, and this cycle would repeat itself. And once everyone is satisfied with the look of that garment, a pre-production sample will be requested, and from there, bulk production will be triggered. Kind of relatively average timeline for this process, depending largely on the complexity of your garment, could be anywhere from like 3 to 6 months. And you might be looking at a range between like 2 to 6 samples to get your garment totally production ready, sometimes more. Now, taking a look at the digital design process kind of in contrast. On the left here, I've highlighted some of the aspects process that can be completed within 3D. So, of course, the process begins with the development of a digital pattern, which can be constructed into the virtual prototype. From there, you might undergo a virtual fitting, where you assess the fit and look of the garment on the virtual avatar. You can also use your virtual prototype to extract a 2-dimensional sketch. And you even have the opportunity to preview your grading. So this means that you can review the fit of your garment across multiple sized avatars prior to beginning production. And what you can see here is that by offsetting some of the prototyping and fittings within this digital design tool, you're able to cut down pretty significantly on sample development. So you're essentially replacing this fitting process with virtual fits on avatars. Now, I take this with a grain of salt, because this reflects a kind of highly idealized process. I think you'd be pretty hard-pressed to find a designer that doesn't want to see their garment fit on a human body at least once prior to beginning production. But I think that as these tools evolve and become more commonplace in the industry, I don't think we're far off from seeing a process like this become reality. So we know by now that the use of these 3D tools has some pretty obvious implications for the product side. But I did want to highlight a few user groups that might make use of these tools, including merchandisers, also the production and manufacturing side, including sample makers and garment workers, and marketing teams, as these tools can be used for e-commerce and social media. There are ultimately kind of 2 types of digital garments that are used in the fashion design, production, and consumption process, which are digital twins and virtual prototypes. The digital twin refers to a 3D garment created to replicate sort of the exact appearance and dimensions of an existing physical garment. And the digital twin is this very high fidelity replica that can be used kind of in lieu of the real thing, and can help eliminate the need for things like e-commerce and social media photo shoots, and it can obviously be quite a beautiful tool for presentation purposes. On the flip side, creating digital twins requires a very high level of expertise in 3D design tools. Now, as I'm learning in my research, you need this kind of extended repertoire of hacks and tricks to get your garment looking as lifelike as possible. The virtual prototype, on the other hand, is more of like a digital mock-up or kind of a generally accurate representation of a design concept or existing garment. These can be used in the design process to facilitate communication or propose or trial new silhouettes or design details. And the virtual prototype is a bit more of like a flexible tool that can work well during the ideation and iteration phases of design development to work a little bit more quickly and efficiently. So I want to jump into kind of some of the advantages and challenges for each of these user groups. Designers are the most obvious user group of the bunch, and they're using the tool to kind of jump right into. Yeah, of course. Oh, sure, no problem. Yeah, that's a good question. Yes, I would say yes. If we're eliminating the kind of back and forth with the creation of these samples and fit samples, we're cutting down several weeks or even months. which can be a positive thing when you're working with small budgets and compressed timelines. But on the flip side, I think we also kind of need to be careful about how quickly this can kind of allow things like fast fashion, these larger brands to pump out new garments even more quickly than before. Hello, everyone.
Are there any questions at this point where we take a kind of organic break? Oh, look.
Two.
Yeah, so having worked with Chloe before, I really dove into the world and I love to explore it. But the only thing that I was wondering is, while we can see real-time results of simulating the garment and fit, I think what it misses is the quality of fabric. We can't.
So that's actually a great question. I'm glad you asked, because I was just learning. I was catching up on some reading, and I learned about a set of haptic gloves that can be worn to help feel. This is a central problem with 3D tools, is that that kind of the materiality of the garment is lost throughout this virtual fit process. And I'll dig out the name for you because it was entirely new to me. They are called haptX G1 gloves. And this supports kind of the textile handling process. I don't know, could it evolve one day into an entire suit so we could feel the virtual garment entirely? I'm sort of speculating here, but I do think we're maybe not that far off from something like that. Yeah.
Just to add on to that.
Yeah.
So from the manufacturer side, I believe there are swatches that the designer has, and that kind of helps with feeling the material. So larger manufacturers would have volumes of these swatches, and they would pick one.
Yeah, I mean, one day could we be at fabric fairs and we are in virtual booths wearing haptic gloves, feeling new fabric textiles, eliminating the need to kind of bring all these physical fabric swatches into the process.
And my question wasn't a question. I just wanted to see the slide from Dr. Syme. I just want to take a picture because I'd love to send it to him. Dr. Syme.
Oh, Dr. Syme, yeah, sure. I will provide my references list at the end, so those of you who are interested, I'm using a bit of secondary research, but I'll give you a chance to take a look.
Any other questions at this point? No, okay.
Okay. So we were back here. All right. So some of the benefits for designers in using these tools, the use of these more high fidelity prototypes kind of early on in the design process can obviously help us trial new silhouettes and visualize our pattern changes. The digitization process of existing fabrics can allow designers to at least get close to kind of selecting an optimal fabric choice for their garment, as well as experiment with things like pattern, print, color, and graphics. But on the flip side, this can also add quite a bit of time to the work of the designer, with the trade-off being here that some of the workload of the pattern maker is being transferred onto the shoulders of the designer, as they are the ones developing early iterations of the garment's pattern. And this can pose challenges depending on the skill level of the pattern making skill level of the designer. And as these tools kind of become integrated into the design workflow, we may need to be acknowledging and responding to these knowledge gaps. Pattern makers are another kind of key user group that reap some pretty obvious benefits. They are, of course, charged with supporting the designer in bringing their ideas to life. And they create patterns and technical details that support correct cut and construction, providing things like stitch type, seam type, garment specs, and points of measure. And all of these elements support the manufacturer's development of the fit samples and bulk production. In the typical design process, the pattern maker would send their pattern and technical files to the manufacturer and may wait kind of several weeks to see the outcome of their patterns as a proto sample. The outcome of that sample can be impacted by a wide range of factors, including communication problems in that technical package, poor fabric choice on the part of the designer, or errors during that sample making process. But with the use of these tools, pattern makers can have this kind of instant visualization of their work, helping improve the accuracy of their patterns. And I think the images that I've included here on the left by 3D designer Shear kind of give you a sense of just how accurate these tools can be when used well. The image on the far left is the Chloe rendering, and the image on the right is the proto sample. Some of the challenges that pattern makers might face, not all of these 3D tools have quite as refined pattern making capabilities, meaning that the pattern maker might actually be exporting their pattern from the 3D tool and importing it into another 2D CAD tool to perfect, clean up, and get their patterns really production ready. And ultimately, that was a great, kind of question earlier, but these garments, we need to be able to feel them, so they need to ultimately be fitted on a human body prior to production. In a kind of similar way, production and manufacturing can also be using these tools. Some fashion firms might elect to actually have their vendors or suppliers create their 3D prototypes and virtual patterns. And this can help, of course, in the same way that they support in-house pattern makers. This can also be helpful for fashion brands because sample development is quite costly. And usually the cost of creating those 2 to 6 samples is absorbed into the unit price for each garment, something that we learned about in Ronald's talk. Challenges for vendors, of course, integrating new software can be expensive, and it can be quite time-consuming to train their various team members on using these tools. The last user group I wanted to highlight is our marketers. So through the use of the digital twin, which I mentioned earlier, 3D tools are also playing a role in the way that marketing and e-commerce content is created. So thanks to 3D's really highly realistic fabric, trim, and stitch properties, the use of these virtual renderings can quite convincingly replace the real thing. You can rig studio lighting just as you would in an in-house studio, as well as, and this can play a role in kind of helping ensure consistency across your product shots. For those of you in the room who are independent designers, maybe there are some of you, this can also play a role in offsetting some of the cost of that marketing process. Another kind of interesting strategy that I wanted to highlight was that you can, through the use of these kind of really high-res images and videos, you can actually kind of test the appetite or success of a sort of theoretical design prior to production. So allowing you to capture kind of more accurate projections for sales quantities and eliminating unsold stock later on down the line. Some of the drawbacks here, again, the creation of these digital twins can be quite time-consuming, and you might require a very highly skilled 3D designer to make them. And creating a truly lifelike garment can also be a challenge. I think these tools are more oriented towards perfection, and we all know that there's kind of a level of imperfection inherent in the creation of physical garments. So getting them to look kind of have that truly lifelike quality can be quite difficult. So what I'm trying to kind of capture here is that the use of these 3D tools can benefit a kind of wide range of professionals involved in design, production, and consumption, and that the tools can be used holistically throughout many of these processes. In physical fashion processes, designers and pattern makers rely upon dress forms and live fit models to evaluate the design, fit, and construction of a garment. So dress forms are cloth-covered mannequins that fit the dimensions of the brand sample size. In women's wear, this would often be like a size small. Most brands will also fit their garments on live fit models who fit within this sample size range. So in addition to modeling the garment, the fit model can offer feedback and test out new styles, giving comments on their fit and functionality. In virtual fashion, it's the avatar that fulfills the role of both the dress form and the fit model. And for those of you that were here for Hayley's presentation, we learned about the importance of fit and some of the challenges associated with standardized sizing. The reality is, I think, despite the fashion industry's insistence that we all fit neatly into these categories of small, medium, and large, which helps simplify their production processes, we know that anthropometric data can vary quite widely from person to person. The creation of bespoke or made-to-measure garments can be quite time-consuming to make. So you need to take kind of extensive measurements of your wearer. You might need to draft custom blocks and patterns, and the client will likely take part in several rounds of fittings. But there are also kind of huge benefits to creating this kind of garment. Clothes that fit us well allow for movement and comfort, and they can also play a role in extending the garment's lifespan because clothes that fit well are usually kept for longer, mended, and are less likely to end up in landfill. The use of custom avatars in the virtual design process can remove some of the labor associated with the development of bespoke or made-to-measure garments, improving their accessibility to the average user or consumer, and also playing a role in scaling these processes. Broadly speaking, there are kind of 4 types of virtual avatar. First, the system internal avatar, which are the preset avatars available with the 3D software. Next are dress form avatars. They're usually supplied by the makers of physical dress form, reflecting their exact dimensions. Using this kind of avatar minimizes the chance of fitting errors across a virtual prototype and physical garment. Next is the scanatar. And this form of avatar is created from data gathered during a 3D body scan. So a human model would first be scanned, and then the data would be imported into the 3D software to create this custom avatar. And the last option is, of course, the character avatar. You can use third-party platforms like DAZ to create these highly customizable avatars and characters that can be used also in 3D tools. So depending on your virtual scanning method and the use of your 3D prototyping tool, there's a few different body scanning workflows. But I did want to highlight this kind of quick and easy method using CLO, beginning first, of course, with your recruitment and selection of participants, then the body scanning process and the collection of the anthropometric data. From here, you can extract an OBJ, which a tool like CLO will rig with the skeletal structure and add skin. And from there, your avatar measurements will be linked to that data that you collected, and the avatar would be ready to be used. There are a few different ways that you can body scan. Options include fixed booth scanning, smartphone scanners, professional handheld scanners, and of course the flexible tape measure. Fixed booth scanning is the most expensive but efficient option, scanning the body and capturing both linear and circumference measurements. In the apparel industry, this is still kind of a preferred option for efficiency and reliability. Professional handheld scanners are more flexible, portable devices used for capturing either full body or body part or limb data. Smartphone scanners are a quite affordable option that capture data using photographs or video footage. While they're not quite as reliable as the first two options, this technology is quite rapidly improving and has some direct benefits for retail, as if you're able to complete a body scan of yourself at home, it can play a role in supporting virtual try-on technology, helping you select kind of the right fit when you're online shopping. And then, of course, there's always the old-fashioned flexible tape measure, which is a convenient and cheap alternative to these options, but can be generally less efficient with more room for error. I wanted to talk a bit about a function of 3D tools called flattening. The use of these tools sort of works complementary to the body scanning process. So once you've created that custom avatar, you can use these tools to extract pattern pieces directly from the surface of the avatar. So for those of you who have less experience with pattern making, this is kind of a very easy entry point for creating custom garments. These tools are more intended for cut and sew knitwear. So what I mean by that is garments with stretch, because they don't account for kind of excess fullness that would be inherent in woven garments. So they're not going to create darts for you, for instance. And I want to highlight in a moment a really interesting study where flattening tools were used for the development of compressive garments in the sportswear sector. This study, led by Kim and Beitar, looked at the use of custom avatars in the development of specialty apparel. So they body scanned 6 different female models between sizes small and large. And they used those flattening tools that I mentioned earlier to extract pattern pieces directly from the surface of these 3D avatars to create, and then from there created their pattern adjustments for compression. They made use of some built-in virtual fitting tools to analyze compression in 5 different animation sequences, which were kind of relevant to their to sportswear activities. And then they took it one step further, and they actually exported these patterns, cut, sewed, and tested them on human participants. And when participants were asked to compare them against market samples, they preferred the virtually developed options. I think what this study points towards is not only the really highly customizable nature of virtual prototyping tools that I've been emphasizing, but also the efficiency of these processes over more manual methods of garment creation. Okay, at this stage, you've heard me mention virtual fitting a few times. Virtual tools have these built-in fitting functions called maps that allow you to preview the fit of a garment across all areas of the body. And I've highlighted 4 here that are kind of especially important to evaluating virtual fit. Stress maps look at tear resistance, telling us the fabric pressure per section relative to the garment fit on avatar. Strain maps express the stretch or distortion exerted by the avatar on the garment. Fit maps tell us where an area of the garment might be unwearable or where things might be tight. And finally, pressure maps show us areas where the garment comes in contact with the avatar's surface. Now, the images that I have up here show the avatar in an A-frame pose, but there's no reason why we couldn't be, for instance, looking at the fit maps of an avatar, in like a running pose, or evaluating their fit throughout an animation sequence to see how the garment moves as the avatar moves. Virtual garments can also help address the needs of diverse user groups. A study led by Hobbs-Murphy et al. Looked at the use of handheld body scanners in the creation of garments for individuals with mobility differences, including individuals who use wheelchairs. Handheld body scanners are a more flexible tool for capturing anthropometric data in a variety of different postures, including seated postures. I think they can also help meet the needs of groups who lack choice and properly fitting fashion and apparel options, for instance, aging populations and individuals who wear plus-size clothing. And the last kind of interesting benefit, I think, is that the use of these tools throughout the design process makes it a bit easier to capture the feedback of your user as you work and implement their feedback while on the go. What I'm kind of hoping to leave you with here is that not only can the use of these custom avatars support fit and functionality, but they can also help us communicate better with these diverse user groups and work towards supporting their needs. So at this stage, I'm sure that those of you who have been following along closely are already kind of drawing connections between the use of 3D prototyping tools and their benefits to environmental and social sustainability. In this next section, I'll be discussing kind of 3 ways the use of these 3D tools have begun to create tangible environmental and social change in the way that garments are designed and produced. And this includes things like eliminating samples, enabling sustainable methods of pattern cutting, and creating new channels for co-creation with users. This is an often cited statistic from digital-only design firm DressX from their 2023 sustainability report. Production of a digital garment emits 97% less CO2 than production of a physical garment. Production of a digital garment on average saves 3,300 liters of water per item. What this quote suggests, of course, is that there are significant savings to be had during this prototyping phase, but I do invite you to take in the statistic with just a grain of salt. I think it's pretty difficult for us to imagine a future in which digital garments will completely offset our need for material garments. And we also need to be mindful of the energy consumption required for the production and storage of these digital garments. But bearing that in mind, the waste generated from the physical prototyping and design development process can be kind of divided into 3 categories: production, transportation, and end of life. The most central sustainability benefit that I've been talking about at length today are their capacity to minimize the number of samples generated during the development and fitting process. And this refers to the pre-production stage as production teams prepare for bulk production. 3D samples can be minimized during ideation, during the fitting stage, and also during grading. They can support the fitting process quite early on in the design process. In my research, participants reported that they held typically at least 1 virtual fitting prior to developing a physical sample. But I think they have these kind of interesting applications to the grading process too, ensuring that you get fewer surprises once the extended size range of a garment is produced. The 3D tools allow you to preview grading rules on all of your avatars of varying sizes prior to sending these patterns for bulk production. And this can be helpful in evaluating the grading of things like design details or graphic placement to ensure that your size small, the look of your size small doesn't differ radically to that of a size extra large, for example. 3D tool Browseware has this kind of interesting resource savings calculator to gauge the benefit of virtual sample development. And this tool approximates the carbon and water savings of virtual prototypes by category type. So most major fashion brands work in product category silos. So for instance, there might be a product team kind of entirely devoted to denim, outerwear, or cut and sew knitwear. And within these product category silos, your development ratios might span anywhere from 2:1 to 5:1. So meaning that for every garment that ends up in store, there were like 2 to 5 other designs that were developed in tandem. If you are, for instance, a denim designer and you're tasked with developing 10 new pairs of jeans each season, there might be an additional 30 that you develop that never made it into stores. And you could see how this textile waste would add up. Although this is, again, kind of a rough approximation of the environmental savings, it does kind of put it into context, I think, and give people a way of looking at the impact of these tools. think generally speaking, when we think about fashion's environmental waste, we tend to consider the waste associated with either bulk production processes like textile waste, harmful dyeing processes, and textile production processes. Or we might be thinking about garment end of life. So this is how secondhand textiles or garments end up offshored to countries in the global south like Ghana and Kenya. But between those stages, our pre-production samples are shipped in this kind of broad arc between fashion firms, textile mills, and vendors' sample-making rooms. In the mass market process in the West, garments are first designed in the head offices of fashion firms. Technical packages are sent to their manufacturers, often located in Asia. From there, the vendor will make a request for sample yardage from the fabric mill, which will be shipped back to the offices of the manufacturer. The sample will be cut and sewn and then sent back to the offices of the fashion designer. Depending on kind of the company and your fitting process, anywhere from 2 to 6 samples can kind of be ping-ponged between your manufacturers in Asia and your office. Of course, through the use of these tools, we can kind of minimize a level of this back and forth. And I think this is kind of an aspect of environmental waste with the production process that we don't think about quite so often. Another really interesting area that 3D tools can target is post-consumer waste. Somewhere between 80 to 150 billion garments are produced each year, and somewhere between 10 to 40% of these garments are not sold. So this contributes to a very staggering figure of 92 million tons of textile waste each year. I wanted to highlight a really interesting study from Weatherell et al. That explored the possibilities of garment remanufacture using these 3D tools. The authors looked at how they could take existing stock of either overproduced or used garments, and then deconstruct them and import their patterns into 3D tools for this kind of redesign and remanufacturing process. And their findings suggest that these methods of recreation would allow for a pretty significant amount of secondhand textile waste to be repurposed at quite a low cost, promoting the circularity of these unwanted garments. I think not only can this tell us about the role that these 3D tools can play in eliminating textile wastage, but also new ways of considering a garment's end of life from the very early stages of design ideation. So designers who are looking to extend the lifespan of their garments, they might need to begin thinking about not only how can this design be usable for somebody, but how could it be cut apart in the future and repurposed to be useful for somebody else. In addition to reducing sample development, these tools also facilitate more sustainable methods of design and pattern cutting that would be otherwise quite challenging and resource intensive using manual methods. Zero waste garment making is a form of design practice where the entirety of the fabric yardage is used in the design and pattern of the finished garment. So it's an approach to pattern making that completely eradicates textile waste. And one of the challenges with zero waste pattern making is that it's not very scalable, partially due to kind of the nature of the complexity of developing these garments. Hilary McQuillan is one of the most prolific zero waste designers, and she looked at how she could integrate these tools into her workflow. Typically, when you're doing a zero waste pattern, you need to do kind of numerous small scale mock-ups and some kind of educated guesswork in pattern design. But the use of these tools in her process kind of had a marked improvement as she was able to kind of evaluate her pattern moves and decisions immediately through the use of the 3D visualization window, resulting in a more precise workflow. They've also proven to be an efficient add-on to the process of kinetic garment construction. This is a form of design and pattern making that centers the movement of the body in garment creation. So traditional pattern making methods require measurement of the body in more static poses. And the use of these 3D tools in kinetic garment construction allows the designer to evaluate the fit of their garment while in motion using those animation sequences or motion poses I was talking about. And this results in garments that adapt along with the body's movement and as it grows. Kinetic construction can improve comfort and functionality, promoting, again, this kind of greater garment lifespan that might exist in the user or wearer's wardrobe longer than more conventional garments. And finally, I think maybe most importantly to many of you in this room, 3D tools can support greater levels of engagement with your end users, resulting in design outcomes that fit their needs. As a junior human-centered design researcher myself, I'm really interested in these benefits, because I know involving the end user in the design process creates more empathetic and useful solutions to challenging design problems. Hong et al. Highlighted the use of 3D tools in the co-design process, as they used 3D prototyping to create design options for people living with scoliosis. They developed a framework of design, display, evaluation, and adjustment, which can help involve the end user throughout the entirety of this design process, leading to more user-focused solutions. Huggard and Sarmakari's case study research on the digital-only design firm, The Fabricant, looked at their project, The Fabricant Studio, which allowed individuals with no prior design experience to collaborate with digital artists, designers, and brands through their Discord channels. This kind of collaboration can create new opportunities for individuals to get involved in the design process, and can at least kind of partially democratize access to apparel design, as anyone who has an internet connection can get involved. The connection here between human-centered design methods and sustainability is that garments that fit our functional, expressive, and aesthetic needs tend to be worn for longer, are more likely to be mended, and are less likely to be carelessly discarded. And using these 3D tools in the development of specialty and adaptive apparel can help you connect with your user group early on in that design process and transcend some of the barriers associated with physical garment making. And on that note, I'd like to leave you with just a few kind of key takeaways from today's presentation. The scope of digital fashion is quite broad and includes more than just digital prototyping. Virtual garments for the metaverse and Web3, wearable technology, and marketing assets are all under that kind of major umbrella. While these tools are still kind of in their infancy, major brands are leading the charge with adoption and helping define this kind of evolving digital design process. When used well, the use of these 3D tools can reduce speed to market. And I think that they can be used by more than just this primary user group of designer. Pattern makers, merchandisers, vendors, and marketers are all among these key user groups. Virtual avatars have, I think, direct benefits for the development of adaptive apparel, and these body scanning workflows are becoming increasingly simplified. Through making use of things like virtual fitting, pose, and animation, you can perfect your fit, or at least get it as close as perfect as possible prior to developing a physical sample. And then finally, there are some pretty interesting sustainability benefits to the use of these tools. While they have quite obvious impacts on textile waste, they can also support these kind of alternative paradigms for fashion design, supporting pattern cutting methods like zero waste and kinetic garment construction, and as well as fostering these kind of improved feedback loops with your end user, fostering cycles of co-design. So on that note, thank you very much for listening in today. I would, if I could, just before we start, for those of you who are interested in some further reading, I would just kind of like to highlight some of the studies that I talked about. Feel free to take photos if you'd like. And that is the second one there.
And we will make these slides available also if anyone is interested in following up on those incredibly useful references. Thank you so much, Millie. A very comprehensive talk around virtual fashion and the use of avatars. So we're going to throw it over to questions. Who has a question?
Hi, thank you for sharing all of those, amazing research that you've done. I'm sorry I'm half an hour late.
It's okay.
Due to the subway problem. My question is, in all of your research, as far as time goes, because when you produce anything, when you employ, send it to another country, you have no control over how they're going to be produced, and I know for a fact that a lot of the foreign factories, it's all about time. Yeah. So in this particular case, in your research, is this fairly, time efficient as far as?
Yeah, I would say yes. I'm not sure I can give you a totally precise answer to that question, but I would say for the most part, when the process is kind of perfectly integrated and the tools are being used well, it can cut down months on your development process. Yeah.
The other question is, so you mentioned earlier that it's still in its infancy, correct?
Yeah.
So there So obviously there are many different software.
Yeah.
And so far, which is the one that's sort of, more advanced than some of the others that you found?
I would say quite a few. A lot of designers that I know and work with prefer Clo because it's quite a user-friendly tool and it has very strong visualization capabilities. People who are more oriented towards user groups that are more oriented towards fashion production or pattern making might prefer a tool like Browseware, which has quite comprehensive pattern making tools. Yeah.
Thank you very much.
Do you have some questions?
Thank you, Millie. I was wondering if in your research, your secondary research, or even your primary research, or even feel free to maybe give your personal opinion, if you found any, I don't know, if you found any implications for this tool to assist in the decentralization of fashion, or even, even on a smaller scale, sort of like maybe minor disruptions of this more dominant global fashion supply chain?
Oh, that's a good question. I think digital fashion on the whole does, in some ways, kind of disrupt more conventional processes of fashion production and consumption, as kind of the barrier to entry to becoming a digital fashion artist is quite a bit lower than becoming an actual fashion designer who deals with the material creation of garments. Digital garments tend to be less expensive. They can be a little bit more accessible for people who have internet connections, of course. I would say that would be kind of one way in which it's offsetting. But I also think that study that I highlighted by Weather et al. Is also a really interesting example where, again, we're getting designers to kind of think about not only basically the end of life of the garment from the very early design stages, thinking about kind of how things can be repurposed and reused for other user groups. Because these textiles, even though they're discarded and we've kind of decided we don't have any use for them anymore, often they're still in pretty good condition and can be repurposed into something new. So, yeah.
Helen, I've got a question over here. So Millie, thank you. Apologies for the late arrival. My name is Garrick Ing. I'm with the Kite Creates team. We're closely with Helen and company to deliver events like this. And I want to first formally acknowledge and welcome our friends from North Bendale and the Toronto District School Board. So we just came off, yes, all the noise, all the love. So we just came off an amazing walkthrough and they had a chance to see and experience some of the great work that we do here in our Kite Labs. And they are a curious bunch, I could tell you firsthand, because we had lots of great questions downstairs. So I'm going to distill a couple of the ones that I have from this group who have a particular interest in kind of environment and sustainability themes. So I think you spoke a bit to this first one, but I'll give another platform to you to comment. And this is, how might we combat this tendency towards cool fashion or fast fashion, or how might some of these approaches help address the environmental impacts of fast fashion trends? That's the first one I have for you.
Yeah, I guess it could be a little bit of a double-edged sword. What I would like to say is that the use of these 3D tools, I think, kind of centers not only pattern cutting, but also thinking about kind of cut and construction, thinking about your garment, the creation of a new garment in kind of different ways than you might be if you're just a bit more maybe passively creating a two-dimensional sketch and handing it off to someone else. So what I'm kind of hopeful for, and I think when you can kind of see that in the zero waste pattern making and kinetic garment construction, pieces that I spoke to earlier, that these are creating like more accessible ways to work with these 3D tools and experiment with sustainable pattern making methods. But I think where it can kind of be a double-edged sword is this, because these processes are becoming more efficient, it can kind of perpetuate these even more rapidly increasing trend cycles. I think as consumers, we try to do as much as we can to kind of combat that. But I'm hopeful that some designers will be using these tools to think a bit more consciously about their practices. Yeah.
Thank you. I know you have extensive kind of experience in traditional fashion as well. So there's a lot of questions around just lowering the footprint of fashion generally, right? So whether it's water consumption or use of dyes or other harmful chemicals, do you have any comments on that? Recognizing it may be beyond kind of just the scope of digital fashion. And I do see that question. And before you answer that, to buy you a minute to think, I'm noting a question coming in at with Menti. So friends here, obviously feel free to call an audible and we'll get a mic over to you. For our friends online, menti.com, I think the code was shared earlier. Please feel free to share your questions now and we'll do our best to incorporate them into the chat. So with that.
I guess my perspective there is, I would like to see us turn more towards methods of keeping garments in our closets for longer, as opposed to focusing on making production processes, as opposed to kind of, I guess, trying to eliminate water consumption and energy consumption throughout the production process. I'd like to see us maybe consume a little bit less. I think a good way to start is kind of learning how to repair your own clothes, how to sew on things like buttons so that you don't need to be discarding garments once they have small holes in them or small stains. If we're able to kind of slow down how much fashion we're consuming each year, I think that will have repercussions on the industry as well too. So
it's a great perspective. Are we learning how to repair our own clothes yet? Maybe?
Yeah.
Yes. Amazing. Two hands. Helen, there's one in the back as well. But why don't we start with Hayley?
I just had more of a comment and not a question. But I've always thought about these tools for the ease of mass customization. If we can digitize this process as thoroughly, and so individual designers can be making one garment at a price point that is actually accessible to consumers. That's what makes me excited about these tools as well.
Yeah.
Helen, while we maybe march the mic to the back, I'll jump to Menti. So I will just kind of read verbatim here. Is there a future of body scans that are able to capture the actual movements of the subject that might be important for designing adaptive wear for a subject with specific medical or physical needs?
So I guess my answer to that question would be, it would be kind of like a joint process. I guess it would be sort of, I would say you'd begin with a body scan to develop the initial avatar, and then you could be making use of like a mocap studio to be capturing motion sequences that you could be then applying to the avatar. You could, once you've like got that animation sequence rigged on your avatar, you can pose it in a variety of sequences to take a look at how the garment is fitting well in motion. Yeah.
Right, a lot of terminology sprinkled there. Just
motion capture studio. Yeah. That's what a mocap is. Yeah.
Yeah. Me plugging why we love to have conversations like this. Like we and a few of the kite scientists that are part of this community were on site in a film set with virtual production workflows, and we actually had a great conversation looking at different motion capture rigs. So this for folks especially on this side. If you watch any of like the new animations that come out, a lot of this are not just purely computer generated. It's using actors and you capturing their motion and then putting that inside a kind of a computer environment where you change the look and everything. So that a lot of that happens in Toronto. We have an amazing film industry. So just watching the collision of this technology live in Toronto-based film studios, I think the opportunity to do as you were describing is there in front of us. So maybe that's a future talk for us. Right, Helen, I think you've marked, oh, there we go. Question in the back.
Actually, I have just a comment for the young people, folks there. I think the important thing is if you're buying anything, you have to look at the quality. Material is really important. Like I've had stuff that I've worn since I was a teenager. I still have them because of the quality and they last. And then fashion as well. Don't be influenced by what people are wearing, because you should be picking something that you like and that would look good on you, because that makes you stand out. You don't really want to dress like the masses. And so quality is really important, because there are some material that won't last. So if you know the quality and the make and how it's sewn together, that's what you should think about. And simplicity as well. Things that will last, like zippers or anything like that. Just don't look at the fashion and say, I like this. But if the material is no good, you can probably only wear it for 2 years. You wash it, sometimes you wash it once and it deteriorates. That's what I want to share with the young folks there.
Thank you for that advice. So look good and feel good. And part of clothing that makes you feel good is knowing that it's better for the environment. So I know that we're talking to the right kind of group here that when you understand that you have made a choice, right, in your clothing that is better for the environment, hopefully that itself is a good reason to be wearing what you're wearing. So Helen, I don't know if there are other questions as I scan this room, this side of the room. If there are other questions,
Any others over
let me
this
know.
side? Oh, yeah, right.
Talking about motion capture, I'll speak loudly.
Okay.
We have now my company dealing with creating avatars exactly for what you're talking about, the digital twinning, and also for the Web3 immersive retail opportunities that are coming. And going into a motion capture studio is just not feasible if you are looking to buy something and size it. So we're working actually on a solution where your computer camera will capture your body and give those measurements.
Wow.
So something interesting about this.
Thank you for sharing that, because that's not really my area of expertise. So I appreciate the perspective. Thank you.
Are we finished with questions? Oh,
I just have a comment. I wanted to thank you for your amazing presentation, and it's so informative, especially all the resources. And also add that I was very interested in when you shared that before actual production, we can use it for marketing purposes and for getting feedback by marketing on the colorways, whatever works, what's most successful design to produce after.
And that has huge bearings to sustainability too, right? So if we're able to, get a better sense of who might be interested in buying the product and how many, what kind of quantities we should be producing, that results in less unsold stock later on down the line.
Exactly. And I think most recently, Chloe has an update which allows AI feature. So for marketing, you can put any face of the model, save the time of photography, like the whole shoot, but you can record the animation for advertisement.
Yeah.
So thank you.
Thank you.
I think Hayley has a comment or question.
Hi. I was just wondering, based on all of your research, everyone that you've talked to, where do you feel like we are in the adoption curve of these technologies, like across big brands, I think specifically?
That's a good question. I think I can't give you an exact number for sure, but I think in Canada, I don't know, are we somewhere maybe around like 50-50? I think most large brands are beginning to adopt these tools, quite a few in the US as well. I think from the perspective of my participants and the people that I worked with, they are kind of overwhelmingly agreeing that this is the future and that in the next 5 to 10 years, we'll see basically any fashion brand you might work for would be using these tools in some capacity. Yeah.
thanks.
So in the global south or in the east, we mostly use Optitex because of the nesting functions. So that is helpful in manufacturing to reduce the amount of fabric that you use. So I'm not sure if Chloe has that functionality, but a lot of the manufacturers, they use Optitex just because it allows you to use less fabric, which means cheaper production and more sustainable as well.
Thank you.
Yes. Yes. So if you think about the manufacturers, they're kind of primitive in these technologies. So Chloe is sometimes used, but most of the files they arrive in like PDFs, DXF, those kind of patterns. So there needs to be some sort of backward integration for Chloe to fit into those primitive softwares. Primitive, I use that in a very liberal sense.
Thank you.
I do have another question.
Sure.
So I understand the benefits of using this technology from the designer's point of view, but from the manufacturer's point of view, the more samples that come back and forth, the more benefits their bottom line. So do you see any pushback from the manufacturer with this technology, or do you think that they will need to adopt it in order to stay in good relations with the big brands that are now adopting these?
I'm not sure. My research is not really in that area so much, so I'm not sure I'm able to maybe totally answer that question. And maybe you could answer better than me. Yeah. Or Hayley. Yeah. If you have anything to add, feel free to chime in.
So from a manufacturing side, the feature that is super useful is the zero waste feature, because the majority of the emissions that are coming from fashion are from the material itself.
Yeah.
And when you're making any kind of garment, you're throwing away 20% of the fabric just from these offcuts. And by using zero waste methods, you are integrating those 20% waste, and eventually you're not only saving on the cost, the materials, you're also saving on the carbon emissions as well. And this is the major part where you are arresting waste. You know, the overproduction, the remanufacturing that you talked about. Yeah. Those are very minor things in terms of emissions, but the waste, the off-cut waste, yeah. That's the major bulk of the emissions that are coming. And I just wanted to add to the little folks, like how you can reduce fashion emission. Number one, buy less. If you think that, hey, I need this new item or new sweater, new hoodie, just ask yourself, do you actually need it? The majority of the waste comes from, or the emissions come from people and their buying behaviors. If you can buy less, if you can use whatever you already have, that's the best way to be more sustainable.
I love the organic tips. That's my prompt for my daughter is, so do you need this or do you want this? And it's very different. So I actually think we have another question from our North Bendale crew. So if you could share first your name.
Adriana.
Adriana, you have a question for Millie?
Is there a certain fabric that's hurting the environment?
That's hard on the environment? Many. Cotton is a very thirsty crop that requires quite a lot of water to produce. Where do I go with this? The use of synthetic textiles, so textiles like polyester, can also have quite harmful environmental impacts. What else could I add to you? We also thinking about the dyeing processes of fabric is an also important consideration, as the use of synthetic dyes can have runoff and enter our water streams and have kind of harmful consequences later on down the line. So those are all kind of important things to be thinking about when we're thinking about sustainable textiles. There's more I could say, but those are a few things.
We have another couple here. So your name and your question. Did you want to ask your question?
I have a question. What app do you use?
Which of the different softwares do I use? I'm a user of Clo. Yeah.
Clo 3D is
Clo
the
3D,
name of it.
Thank you for your question.
How long would it take to make a sustainable difference using those apps instead of making
a physical garment? Well, I think if we're talking kind of like a small scale production or home projects, you could see those benefits basically immediately. If you can kind of get your garment as close to fit or production ready early on within the virtual tool, you can kind of immediately see the benefits of that process, yeah.
So how will the word get around for younger people to see if they want to
I think the answer is that it's on to you now to go on and spread the word about the use of these virtual tools. But I think they are kind of becoming even more user-friendly, meaning that it's not very hard to kind of, right now it can be a bit more complex to start using these tools, but I think we'll see a day in the future where these tools are quite simple to use and that anyone could begin using 3D software. So I think once we kind of reach that point, it'll be easier for everyone to try them out.
And once you start playing or your parents start letting you play with your phones, I think, Millie, you referenced the OBJ files. These are all fancy words and talk, but I've seen now with your Apple iPhone and a LiDAR camera, you yourself can start playing with spatial mapping and spatial computing. So the technology is getting better and better, cheaper, and hopefully, not hopefully, I suspect you'll all have a chance to be 3D designers one way or the other. Okay.
Actually, I have something to share with the young people going forward. I'm actually in the interiors and architecture, experience for a very long time. in the interiors and architecture, we have the same problem with, specifying furniture and fabrics for furniture. What you have to look for, which I think is coming, and there are some manufacturers for furniture. They actually recycle the water that they use when they manufacture the products, and even like tile companies, stone companies, that you see, on the buildings, that technology is here, and there are, like, especially in Europe and even in the States, sustainability in the interiors and architecture areas is really has been around for a long time, and they're really moving towards that, and it's still continuing, it's still evolving. So that's your future, basically. Even 3D printing, it's all out there already, like bicycles, like titanium. They can print titanium now. There was a bicycle that was printed by a UK company that I've seen, that was 10 years ago. And it only consists of 120 parts, and you can just put it together. That's here, and it's still evolving. And then there's concrete, they're even printing concrete and all that sort of thing. Just so this is your future, and you have so much that you can learn. Thank you.
Well, thank you. I think we've exhausted the amount of time we've set aside for today. So I'd like to thank everyone for coming, and the very lively question period that we've just had. And all of you from North Bendel, thank you so much for joining us, and thank you for adding into a very great conversation that we've just had. And please stick around for networking. There's still coffee left, and there's still cookies, and Millie's going to be around for at least the next 30 minutes.
So one more round of applause for Millie. And I will plug, if you enjoyed events like this, I know this is a bit of a closure of an amazingly successful series we had, spotlighting apparel and technology, but we continue to do events. The next that we've just launched, March 19th, that's open on our Eventbrite. The topic will be, for the architects and designers in the room, multi-sensory wayfinding. So wayfinding is this whole idea. Usually you think of it as signs, right? And signage that helps you kind of get to places. But we're going to look at all the really interesting ways that we're not just using signs, but maybe smell. I've heard you talk about haptics, other kind of textures, even things like echolocation possibly, as like, what are the innovative ways that we're helping people find their way around spaces? So that's going to be our March 19th event. And of course, we'll continue to promote as we hatch amazing opportunities to feature speakers like Millie and cover topics that kind of cover that whole gamut of where is creative technology or creative industries intersecting with health and health technology in interesting ways. So more on that. Stick around. I think there's still some coffee and treats, and let's maybe a final round of applause and goodbye to our friends who have to sneak out to catch their bus downstairs from North Bend. Thank you all for joining us this morning.
Thank you so much. Thanks for the great questions and comments. Yeah. Thank you.